Hello everyone, welcome to this video where we will be touching on how to find null or missing values using pandas and how to deal with that missing value through the use of pandas. And we are going to do that while using Google Colab. So without further ado, let's get started. First, finding null or missing values. How can we find null or missing values? But before that, what is missing values, or what is the definition of a missing value? When dealing with datasets in Pandas and Python, missing data is data that is not present in the dataset at hand, and they're usually represented as NaN values. And that could be due to a multiple of factors like human error, incomplete observation, and even improper maintenance of data. In this tutorial, we will be exploring how we can find out the missing data within our data frame and explore different methods for handling missing data. This tutorial is part of a tutorial series that aims to explore the different important and essential functions and methods of Pandas for data analytics. So if you're interested, check out the description for more links on the articles this video is based on Medium, and the previous video of this tutorial series. In this video, we will be working with an additional dataset, which is the Melbourne housing market dataset. And in this dataset, we have a lot of values ranging from the suburb details, the address, the rooms, the prices, and the method that these houses were sold, whether it's a property sold or sold prior, past in, etc. So we have a lot of features, we have a lot of columns that describe the Melbourne housing market. And this dataset should include some missing data. Therefore, it's a good opportunity for us to exercise what we will be learning here today. So back to our code. First things first, of course, remember, if we're going to upload any file over here, this Google Colab, when the sessions are terminated, these files all disappear. So a better practice would be mounting our Google Drive and uploading our files over there. But since this is just a tutorial, you could easily just click on the upload button and choose and highlight the data that you'd like to upload, or even open a file in front of you and drag and drop. So we will be working with the Melbourne housing dataset. I'll go for the full dataset. You can go and see the less dataset, but I'll be working with the full dataset. So as we've learned in our previous videos, we need to import pandas and numpy in order for us to look at, visualize, and manipulate this data. And we're going to import this file over here, which is in CSV. Therefore, we're going to use read_CSV. If it was in Excel, we will have used read_Excel. And we're going to take a look at that dataset. What do we have? Look at the data frame that we've uploaded. We could see that we have about 21 columns. We have the suburb, the address, the room, the type, and we have different categories for type, where we can see over here the clarification, the type, unit, or town, or house, townhouse, sorry, or house, okay, etc. And we have a lot of details over here. We have 21 columns. Now, another thing we learned in our last video was the in.info, right? And this gives us a view onto our data. What is our data types? Do we have any null values? And we can infer whether or not we do have null values by the count of those non-null values. So we can see we have about 34 or 35,000 values for suburb, but when we come down to bathroom and car, we have much lesser than that. So this clearly seems like this data has missing data that we need to handle and detect. So how can we detect this missing values? How can we count them? How can we see whether or not there are missing values in this data frame? Well, the method that we use is called isnull. And let me check if I spelled it correctly? Yes. And when we run that, we get the whole data frame returned back to us with false or true values representing whether or not this specific data is a null value or not. So in this specific row and column, the data over here is not a null value. It's not a missing value. However, when we look at the price in the third row, we will have a missing value over here. So if I come back here and I comment this, and I showcase the first three rows, when I look at price, or let's say the first four rows, I can see that I do have a NaN value in my third row, or my fourth row, sorry, in my fourth row. So let me comment this and uncomment this. So in the fourth row, we have a true value here, which represents a NaN, and as well as the first row. But this is not a really practical way of visualizing missing values, isn't it? A better way would be if we had the sum of null values in each column presented to us. That would give us a better idea on which columns or features of our data have some issues regarding missing values. So we can see that we have some issues with price, a little bit of missing values over here, and a lot of missing values at the later end of this data frame. Now, how can we deal with these missing values? After identifying missing data, we can handle those missing data through multiple approaches, such as dropping the columns with missing data, dropping the rows with missing data, assigning them through a descriptive statistic of their respective column, or even replacing the missing records with other data or other values. And we will be walking through each option presented in the slide and taking a look at when they may present a viable possibility and when they may not. The first approach we talked about, or the first two approaches that we talked about in handling missing data, were dropping the columns with missing data or dropping the missing rows. However, it's really important to keep in mind when choosing these approaches or these methods that we risk losing valuable information from our dataset. But before looking at when these options of dropping columns with missing data or dropping rows with missing data can be considered a viable approach, and when we can actually use this to our benefit, let's look at how we can actually remove missing data from all the rows within our data frame. And we can do that using the drop NA method. So I'm going to create a new data frame, and I'm going to drop all the rows with missing values just by using the drop NA method. So if I'm going to do that and then using the isnull method, taking a look at what that does to our data set, we will get the following. We will get all the columns with 0 null values, because what we've done right here is drop all the rows that contains null values. When can we consider dropping rows a viable option? Well, we can consider it a viable option if those rows are affecting our data quality. Null values represent missing or unknown information in a dataset. By removing rows with null values, we can improve the overall data quality and integrity. And another option as well, where we can deploy removing rows with missing values, is if it's going to affect our statistical analysis. Many statistical methods and algorithms require complete data to provide accurate results. Null values can affect calculations such as averages, correlations, and regression models. Removing rows with null values can ensure that you have a consistent and a complete dataset, enabling you to perform robust statistical analysis. But remember, sometimes dropping too much information will also skew or affect your analysis. So Make sure to use your judgment wisely when dealing with missing values and dropping them, whether it's dropping rows or dropping columns. Now, what if we wanted to drop all the columns with null values, meaning that we would like to drop all these columns, the price column, the bedroom, till the end, and we will be only left with 7 columns that have no null values. So how can we do that? To do so, we can either use this method, where we drop the null values for 1, meaning that 1 indicates that we're trying to remove columns that contain null values, or drop an A, and in between quotation marks we specify that we would like to do so for columns. And when I do that and I display or preview the data frame or the head of the data frame, I should see only 7 columns left. So let's do that. And I get this. I get 1, 2, 3, 4, 5, 6, 7 columns as expected. When would dropping columns be considered a viable approach? Well, it could be considered as a viable or a good approach to dealing with missing data and handling them if it were to drop irrelevant or redundant features. If a column or a feature in a dataset does not provide any meaningful information and can be considered redundant, then dropping it can simplify the dataset without losing valuable insights. As an example, if a dataset had a column representing a unique identifier or a timestamp that to us we find irrelevant in the analysis we're trying to perform, then we can drop it without risking or fearing losing information that would be really important to us. Another thing that dropping columns could really help with is high dimensionality, and it would help reduce high dimensionality and mitigate the curse of dimensionality. But what does that all mean? High dimensionality means that a dataset has too many features. And remember, features is just another word for columns. So high dimensionality means a dataset that contains a lot of columns, a lot of things describing it. So when dealing with high dimensional datasets, dropping some columns can reduce the dimensionality and of course mitigate the risk of high dimensionality. But why would high dimensionality be a bad thing? Well, when modeling data with high dimensionality or high number of features or high number of columns, it can certainly increase the model's complexity and can produce an overfit model, which in turn makes it computationally inefficient. By removing irrelevant columns, we can reduce the dimensionality without significant loss of information. Also, if a column has a large number of missing values, imputation or replacing those missing values with other values can seem like it's not feasible or appropriate. So therefore, dropping that column as a whole might be a better option than filling the whole column of missing values with values, because that could introduce bias or an inaccuracies in the dataset. So in this case, it might be better to remove the column altogether. And finally, in feature selection, dropping columns is really great because in cases where we may need to build a machine learning model, we perform feature selection, which is a fancy way of saying that we're going to choose and select features or columns that are meaningful for us to create a model that will present the output that we're trying to present. So feature selection aims to identify the most informative subset of features for a given task. And to select features, we can remove features that we don't want. So therefore, by dropping irrelevant or redundant columns, we can improve the model's performance if we're trying to model the data at hand, therefore reducing overfitting and enhances interpretability. So let's use the information we just acquired at hand. We said that it could be great if we can reduce the dimensionality of our dataset, especially if we're trying to model a given data set. And remember, we have over 21 columns over here. And we can see that some columns have a lot of missing data, such as land size, building area, and year built. And maybe dealing with them in other ways may not be as viable as we may think. So we can say that we can drop the column with the largest number of missing values, such as the building area. So that's exactly what I will be doing. So how can I drop a specific column? We can do the same thing, but specify the column at hand. So we can say df.drop without an a, since we're not going to drop all null values, we're going to drop one column, and we're going to specify that column's name, and we're going to have the same data set but missing one column, which is the building area. So if I'm going to say isnull dot sum, we should not have building area over here. So we do not have building area. In this video, we took a look at how we can understand if our dataset contains any missing values. And we've looked at two different ways of handling missing data, which are dropping rows and dropping columns with missing data. And although they are not feasible ways or do not always present as a good option, we've discussed them regardless to present the different ways of handling missing data. In our next video, we will look at more feasible options and more better options to deal with handling data, which is either through imputing missing data with statistical descriptions like the mean, median, and mode, or using different pandas methods to backwards fill or forward fill, and also take a look at how interpolation can assist and aid us in filling our data. So stay tuned for that video, and thank you for watching.